Hello, so for today I thought we could try doing some more complex things, and we're going to actually try exploring OOP, so Object Oriented Programming. Now, that's fairly useful in programming because it allows you to create objects of things and allows you to create behaviors for certain objects, duplicate things, encapsulate stuff, all the kind of the complex things that go along with programming makes things easier with OOP. So let's get started. So the first thing we're going to talk about is classes. So let's say we have a dog, right? What defines a dog? Legs, tail, ears, nose, stuff like that, right? All the parameters. So if we use that logic and we define a class called dog, so we'll say class and then say dog, and we're going to use capital D because we're defining when you define a class, you usually use capital for the first letter here, so that will be a capital D. That's an O. So yeah, and then we have some logic that goes here. So these are parameters, either data, behaviors, that sort of thing. Now with all classes, you have something called a constructor. So constructor. Now what does that do? So just before you create an object, the constructor is called, and that logic is then applied first. Then it creates your object. So let's say, for example, we wanted to create an instance of a dog. So this is how you create an actual object in your programming code. You would say something along the lines of let. So we're defining a variable called dog. So that's lowercase d. That is equal to new. No, not that. New, capital D, O, G, open bracket, close bracket, and then colon. So what this does here is it creates a dog object. The constructor is then, by you saying new, the constructor is called. It then runs a logic here, creates an instance, so an object of dog, and then stores it into this variable dog here. Now one of the cool things about classes, or at least objects, is you can assign parameters inside the object itself, and that's where the keyword this comes in. So this. So let's say I wanted the dog object to have a parameter that defined legs. So obviously we know that dogs have 4 legs, unless, you know, God forbid they've been in an accident. You would say this dot legs and then equals like a number. So in this case we'll say 4. So it's fairly useful. We have parameters that are associated with the class, we have parameters that are associated with the object itself, and we can work with this logic to do really complex tasks. So I think that covers most stuff about classes. Also, you can have functions stored in them. Functions don't have to have function then. You could have a function called walk, because of course it's a dog. We can have a curly brace. My drawing is terrible. Some logic there, and then a closed curly brace. Right? So let's jump into the actual editor so we can actually have a go at writing this code out. Now, I can't actually draw a dog. So let's actually try. Let me get rid of that. That was something I was trying out before. I can't actually draw a dog, so we'll try making it a rectangle. Yeah? I think that will make things easier for everyone. So let's define our class. So we'll say class is dog, and we have curly braces to define it. We have a constructor, and then we have a curly brace there. Go back into it, and then we will say this dot legs is equal to 4, and then we'll say this dot tail is equal to 1, because we all have one tail, and so on and so forth. But the real things that we care about right now is positioning. So we'll say this dot x equals 100, this dot y is equal to 100, we'll say this dot width, box width, and we're going to use box width like that because if we use width, width is predefined to another variable, and generally when you're using parameters inside a class, you could use the variable width you should be able to use it because it's not that, but because the auto-correcting here, it's a bit confusing, so I'll just use that. Then we'll have a function called walk, and then we'll say this.x is incremented by, say, 20, and our this.y is incremented by 22. If we run this code, it should work. Obviously we have to define our stuff first, so we have to define dog here, so that creates our instance, and then we'll declare our instance here, so we'll say dog equals new dog that, and then we'll say dog here equals walk. So let's see if any errors occur. So no errors occurred, but nothing was drawn. Why is that? Well, we actually have to draw the object to screen. So we'll say show rect, and that will be this.x, this.y, this.box width, and we'll have here dog.show. That's pretty quick. Let's slow that down. Let's do 1, 1. And there you can see the object's being created on screen and it's walking off screen slowly. So with that being said, we can also define another one. So let's say dog, let's name this dog 1. So let's make another dog. So we can say dog 1, and then we can use the exact same logic here and copy and paste that. So we'll have another object now. Dog 1, dog 1. But it doesn't show here because they're overlapping, but I can assure you there are two objects there. In the next episode I can talk to you about how you can put in parameters here to make one object different from the other. So you can make some more complex behavior. We can make the square move here and the other square move here, even though they're part of the same class. But I think that covers it for now. I'll save this piece of code so you guys and gals can have a look at it. Yeah. But this is a fairly, like, this kind of underpins one of the core concepts in programming, understanding objects. Because when you can create objects, you can go with a whole array of crazy functionalities. So yeah, I think that covers it for now. Hopefully, I'll see you in the next episode. Bye bye.